This is Dave Johnson with a faculty development talk called Evidence-Based Science Education. I've been here since the beginning of time, or at least for Quillen. Taught the first class on the first day in August 1978. I lectured with a chalk on a chalkboard and students taking notes. Same way I'd been taught all my life. Continued this for over 30 years. And then why change? Well, in 2012, we moved to a block system, and biochemistry had lectures from 8 to 12 every morning, 4 hours of lecture, and that was deadly for the students, deadly for the faculty. It's very difficult to lecture for 4 hours. And so the students weren't always taking notes or listening or very actively involved. They were just sitting there. Then I saw this paper by Prober and Heath out of Stanford. It was called Lecture Halls Without Lectures, a Proposal for Medical Education, that was published in New England Journal of Medicine in 2012. And they said that basic medical education had not changed in 100 years, and they proposed a flipped classroom model with digital lecture homework, class time applications, including emotion-provoking simulation exercises. And Stanford Biochemistry had redesigned their course following this model with short online lectures. Class time was interactive with clinical vignettes highlighting the biochemical basis of disease, and class attendance increased from 30 to 80%, even though class attendance was optional. Now, the flipped classroom has evolved over time. The Khan Academy started doing online videos, educational online videos, back in 2006. And Salman Khan draws on a black surface with different colored pens. And usually those videos are like 10 to 15 minutes. As he's talking, you never see him on the video. Now, we started doing integrity lectures and integrity recording lectures. They're too long because students don't like really long videos. TED Talks are limited to 18 minutes by even polished speakers, and so we need to shorten the lectures. MOOCs are massive open online courses, and very few MOOCs are actually completed due to the fact that they are also long, and quite often it's just somebody standing at the screen talking. Osmosis.org videos started in 2012. Osmosis.org is a very interesting organization. It is started by some medical students at Johns Hopkins, and they have some really neat little videos. All their videos are drawings, sort of like the Khan Academy, but they are on white. They're different colors on a white background, and they limit those to between about 4 and 17 and a half minutes. In 2013, I started recording lectures and posting them on YouTube, and that was sort of our first attempt at flipping. Cellular and molecular medicine or biochemistry in 2012 was a traditional lecture format. In 2013, we had partial flipped and traditional. In 2014, partial flipped. In 2015, flipped. And 2016, flipped. And the success rate for shelf scores went up. You can see from 2012 to 2016, we had a very nice increase in our on the shelf scores in biochemistry. Also on the number above the 90th percentile and above the 80th percentile increase. So our better students did better. We also had our lower echelon students also did not do as bad, so we had fewer failures and fewer low grades. Student evaluations of the course went up, and that made us all happy, especially Dr. Olive. And then increased CMM classroom results, increased attendance, improved shelf scores, better student course evaluations, higher student course exam performance, fewer low grades and course failures. Student reported more free time. Videos and notes, we all do it a little differently. I record my videos in my office using Camtasia Studio, and so I record my PowerPoint on the screen with voice and have a nice mic, and then I post them on YouTube. My videos are broken up into about no more than about 15 minutes each, and sometimes a little shorter than that. And there will be about 30 to 40 minutes of video for for the class the next day. Dr. Robinson also uses Camtasia, and he records drawings on an iPad and voice, and he posts his on the YouTube. Dr. Rusinal uses Articulator, now known as Storyboard 360, which develops learning modules with voice and integrated questions so they can branch off and take questions on different topics as he progresses through the learning module. Dr. Tefke uses Adobe Presenter to produce e-learning modules that also include questions, and he posts those on D2L. We also provide notes. We prepare our notes in MS Word with the same or similar figures. Students really like the similar figures. If you change figures, they get a little upset about that. And PDF format, also, we provide those in PDF format, and they're on D2L. And some students have those printed out, but a lot of them just use them online. Practice quizzes on D2L. We provide practice quizzes. I keep only the highest score recorded. I do not limit the number of attempts, so students can really work on these until they can answer. Most of those practice quizzes are just very basic information, don't have clinical vignettes in them like step 1, but they do have, it's like the basic information such as what's the structure of, is alanine a hydrophobic or hydrophilic amino acid, for example. In class, we from 8:30 to 9, they take a 10-question quiz on D2L, and attendance is required for that. Quizzes are individually. They take them first individually and then as a group. We have 31 quizzes this year, and the 5 lowest scores are dropped. That results in 10% of the grade. Then from 9 to 10, we discuss clinical cases in class with turning point attendance response. They can use that on their phones, PCs, and tablets, so they can interact as they go. And sometimes we have competitions in class, the left side of the class, the right side of the class, or different people, small groups, and things of that sort. They can compete. They kind of like that. To 10 to 11, sometimes we have clinical presentations in which clinical faculty and M4 students come and present clinical cases, and that attendance is required for those as well. Now, the M4 students are absolutely fantastic because they can remember being in that class, and they can relate to students even better than faculty quite often. Then we have 7 or 8 small groups. I think this year we have 7, but quite often we've been having 8. We have small group case discussions where we discuss a disease. Each faculty member takes 3 groups of 6 students at different times, like 1 o'clock, 2 o'clock, and 3 o'clock in the afternoon, and attendance is required for that. We spend 45 minutes to an hour talking about that case, and the students interact with each other and with the faculty for that. Instead of giving review sessions, we use practice exams with half the number of questions on a regular exam. We use ExamSoft for that. Students have really found this useful. This is another way for them to test their readiness for the real exam. Students must have a 70% average on the exams to pass our course. So the quiz grades count on class rank, but not on whether you pass the course or not. You've got to pass the exams. We have lots and lots of formative assessments, quick quizzes, clickers in class, and practice quizzes, more than 1,500 opportunities for them to test their own learning. Now, there was a paper published in the Proceedings of the National Academy of Science in 2004 that I found last year, and it's called Active Learning Increases Student Performance in Science, Engineering, and Mathematics by Freeman. Their hypothesis was that lecturing maximizes learning and course performance. Anytime you do a research study, you need a hypothesis. They did meta-analysis on 225 studies, reporting the comparison lecture versus other forms of active learning, and they looked at exam scores and failure rates. This is for undergraduate STEM courses in U.S. universities. The average exam scores increased 6% with active learning versus lecture. Students were 1.5 times less likely to fail with active learning. Increased scores on concept exams. These are external exams, sort of like step one, our shelf exams versus core exams they had versus the course exams. It was not instructor dependent. Consequently, the hypothesis was rejected. Lecturing does not maximize learning. Active learning maximizes learning. And here are their data. You can see lecture versus active learning in figure A, in decreased failure rates and better active learning. And so the amount of decreased failure is quite significant. And then active learning, the percentage of students who fail classes much better. So the students are performing much better. They're shifted to the right. So poor students do better and good students do better. The discussion on this paper read, the data reported here indicate that active learning increases examination performance by just under a half a standard deviation, and that lecturing increases failure rates by 55%. The heterogeneity analysis indicate that these increases in achievement hold across all the STEM disciplines and occur in all class sizes, course types, and course levels. Active learning is particularly beneficial in small classes and at increasing performance in concept inventories. The discussion continued. The instructors who implemented active learning in these studies did so as volunteers. It is an open question whether student performance would increase as much if all faculty were required to implement active learning approaches. Active learning is a form of learning in which teaching strives to involve students in the learning process more directly than in other methods. In active learning, teachers are facilitators rather than one-way providers of information. There's lots of one-way you can get information. So examples of active learning. Physicians learn by treating patients. Scientists learn by doing experiments. Anatomy labs, active learning, you're dissecting. Clicker questions, audience response in class, that's active learning. Role playing, case studies, group projects, peer teaching, debates are all active learning methods. POGIL is process-oriented guided inquiry learning, and it's supported by the National Science Foundation, and it's used a lot in chemistry, physics, and math, and it's used in health sciences at ETSU and over in the pharmacy school. We have not used POGIL, but I think it might be interesting to try it. Now, in association with the PNS paper, there was an editorial comment by Carl Wyman, and the title of that was Large-Scale Comparison of Science Teaching Methods Sends Clear Message. And he produced these two figures in which you can see that failure rates with lecture are much higher than with active learning, and that concept tests are much better with active learning than with the lecture. So Wyman's comments were that if a new antibiotic is being tested for effectiveness, its effectiveness at curing patients is compared with the best current antibiotics and not with treatment by bloodletting. However, in undergraduate STEM education, we have the curious situation that although more effective teaching methods have been overwhelmingly demonstrated, most STEM courses are still taught by lectures, the pedagogical equivalent of bloodletting. Now, the University of Vermont went to an active learning process a couple of years ago, and this from their website. Active learning harnesses the digital space to prepare students for the work they do together in class. Before they even enter the classroom, students have often completed an online module or digital learning activity that focuses on the topic of the day. Then at the start of the session, each student takes an individual readiness assurance test to make sure they have the fundamental knowledge they need to participate in the group learning. After each session, students are asked to complete a reflection exercise to help further cement what they have learned. This is not too different from what we've been doing at CMM. With so many resources, what's the role of faculty? Our role is to guide students to good resources and aid their learning. Guide students in knowledge application to understand normal physiology and pathophysiology. Knowing why is critical to understanding the benefits and risks of treatments and drugs. So physicians need to understand why, not just what they need to do. Less is more. Medical students do not need to draw the structures of the amino acids, for example. But they do need to know that by replacing a glutamic acid with a valine and hemoglobin results in sickle cell anemia and why that anemia occurs. It is all about our students, not about us. They are native techies. They look for videos just to change the taillight bulbs on their cars. They don't look at the manuals in the glove compartment anymore. Formative tests aid retention, so the more formative tests you can give, the better your students will learn. Applications aid understanding. So in class, applying that knowledge. Medical students need to know, are tested on step 1 now on application, not just recall. And the whole thing is more fun for us. I've enjoyed teaching much more now that I have gone to this sort of system. The end. I always end my talks in class and videos with a humanist sort of quote. It was pride that changed angels into devils. It is humility that makes men and women as angels. A quote from St. Augustine. And there are a lot of others I use as well. So thank you and goodbye.